Let us explore higher order derivatives, the calculus in motion, with the help of this example. What is the difference between distance and displacement? We are going to see it very clearly with this particular example, the calculus in motion. The calculus of higher order derivatives, where the displacement function is differentiated to find velocity, and velocity is differentiated to get acceleration. So, here is a great question for you. Position of a car at t seconds moving along a straight line is given by s of t equals to 1/3 of t cube minus 2t square plus 3t, where s is measured in meters and t is greater than or equal to 0. Now we have to work on displacement at different points and distance traveled in 4 seconds. I am Anil Kumar. Welcome to my YouTube channel, absolutely free for the last 15 years, a learning platform where you share your problems and we share our solutions. Now, let's begin with step by step solution of this particular problem shared by one of the students. We are given that the displacement function s of t is equal to 1/3 of t cube minus 2t square plus 3t. At different times, we need to find the displacement. So substitute t as those values. So let's begin with t equals to 0. So if t is 0, then we can write s of 0. T is 0, right? So this becomes 1/3 of 0 minus 2 of 0 plus 3 of 0. And of course, this gives me 0. So to begin with, the object starts right from the origin. Now let's look into t equals to 1. So if t is 1, then we substitute 1 here in this equation and we get what? Let's see. So 1/3 of 1 minus 2 plus 3. So which is 1/1/3. Or you can write 4/3. Units, of course, are meters. Now let's find what is s of 3. So 1/3 of 3 cube minus 2 times 3 square plus 3 times 3. So let's calculate this. 1/3 of 27 minus 2 times 3 square is 9 plus 3 times 3 is 9. Well, that is equal to 0. Now let's calculate the displacement at 4. So s of 4 will be 1/3 of 4 cube minus 2 times 4 square plus 3 times 4. So that gives you 1/3 of 64, 4 times 4, 16 times 4, 64, minus 4 times 4 is 16 times 2, 32, plus 12. So minus 32 plus 12 gives me minus 20, and 1/3 of 64, when you add to this, we get 4/3. So the displacement at different times is calculated in meters right there, right? So we can write for t equals to 0, displacement is equal to 0. For t equals to 1, displacement is equal to 4/3. For t equals to 2, 3, displacement is 0, and for t equals to 4, displacement is equal to 4 by 3, kind of symmetric, right? Okay, great. So we got the displacements from this particular equation at different times. Now, let's look into the second part, and which is the distance traveled during this period of 4 seconds, right? Now, here, there's one very important thing to understand. When we calculated the displacement in the first second, it increased to 4 by 3, then came to 0, then again increased to 4 by 3. You get the whole idea. So basically, what happened is, let's look into this values once again. Displacement at 0 was 0. Displacement at 1 was 4 by 3. Displacement at 3 was 0. And displacement at 4 was also 4 by 3, right? So this is the kind of result which we got for displacement. Now, how do we relate this with distance? Well, you can see distance always increases with time when you travel. So, in this case, you found that the distance increased to 4 by 3, then decreased to 0, and then again increased to 4 by 3. So, clearly, uh, displacement and distance are two very different things. Distance, we say, is a scalar quantity, it adds on. We have to take the absolute value of displacements to add. Another important thing which is to be mentioned here is what to really add. So we have to find the velocity and figure out from where the particle was turning. So in this case, the car was returning. So we have this function which is displacement s of t equals to 1/3 of t cube minus 2t square plus 3t. Velocity basically is derivation of rate of change of displacement. So let's find the derivative of displacement. So that gives me t square minus 4t plus 3. So if we factor this out, we will know when is velocity positive and when is velocity negative. So that is t square minus 4t plus 3. 3 times 1 works for us. So we can factor it as t minus 1 times t minus 3. So clearly, here we know that the velocity is 0 for t equals to 1 and 3. And those two, we can see, correlate are the turning points for this car's displacement. So what's really happening here, that the car starts from 0, goes, turns right, comes back and goes. You get the whole idea. So since the turning points are at t equals to 1 and 3, so this is t equals to 1, this is t equals to 3. Now from 0, t equals to 0, to t equals to 1, we can write like this. It travels 4 by 3 meters, right? And then it comes back, means again travels 4 by 3, right? And this was t equals to 4 when the position was again 4 by 3. So basically, we have to add all these distances, right? So the distance from t 0 to 1, so that distance is 4 by 3, right? So we'll write this as positive value. Then again it returns, so from t 1 to 3, it again travels 4 by 3. And then from 3 to 4, distance traveled is also, let me write distance 1, 2, and 3, is again 4 by 3. You get the whole idea. And therefore, the total distance traveled is 3 times 4 by 3. So we can write total distance is 3 times 4 by 3, which is 4 meters. Perfect. Now, to show you on a graph so that it becomes absolutely clear for you, we have a graph for you. Now, this graph is of displacement S of t. From displacement, we see that the maximum was 4 by 3 at t equals to 1, correct? Then it came back to 0, and then at 4 also it was 4 by 3. So you can see that the car goes 4 by 3 meters in one direction and then returns. So at this stage, it is going 4 by 3, and then up to here, it comes back 4 by 3, and then again goes to 4 by 3. So those are the three distances which we need to add. Perfect. So as far as displacement is concerned, you can see displacement increases and decreases, where else the distance in this case will be adding on all these displacements, absolute values. So I hope that concept is absolutely clear. So that's the main thing which we wanted to understand with the help of this particular example. We are going to take this example once again, the same equation, to understand many other parameters which relate displacement with velocity and acceleration, mainly speeding, slowing down, when is returning to the starting position, and so on. Follow our playlist to learn more. I hope that makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thank you, and all the best.